I was over here, all credit goes to these people, especially Dr. Sanchez. He made most of it. So, but numerically, there's a way that I need to show you guys, basically. So the way I solve questions is this way. So over here, I put the function in here into this thing. This only works for homework and exams. You have to do table method, which is hard. Not hard. It's just more difficult than the way I'm going to show you. Basically, you go over here and get these 2 points and guess. Like this looks like, I don't know, about 0.25 there, and then over here that looks like 2.4, and that's the Mach number now. That's what I do. Yes, this method is unreliable and very much bad sig figs over here, but with the table method you also have to interpolate and guess, so pick your poison. This is what I do because in the end of the day is a lot of checking, so I do it that way. I just want to show this off because I think a lot of people didn't. This is the way I've been doing it for a long time. In any of my class where I have a big ass equation with a function like this, that's kind of hard to solve for. I don't solve it sometimes. If they give you a number question, I only need to get the numbers out, nothing else. Therefore, instead of doing all the numbers, like you should be doing, honestly, but I do this method, and I try to keep this a secret from people because, I don't want a lot of people to know about it because then, yeah. But now thinking about it, I'm pretty sure all the TAs know I'm doing this, and I don't think it's special anymore. So I'm gonna just tell everyone I do this way because in some of my number heavy classes, just plug in here and get these 2 points, and then you figure it out. If it's like over 100, you know automatically that's wrong because this is m Mach number, which is going to be in the range of order 2 to 10 or something. Most like third definite. I mean, that's pretty much it. The pressure change over here. There's another one over here that goes like this, which is going to be the Mach number showing, no, the non-dimensional way. So it's going to be m dot over rho o a o a e, and this is the p o over p a. Now, what this shows is that at a certain point, there's no change over here, is basically what it's saying. And it looks like the professor is giving out the information over here, which is 1.938. No, no, 1.893, which is given by this equation. Let me double check with Desmos, but you know what? Let me grab a calculator. I haven't used this calculator forever. This is an old calculator that I have just for this occasion. This calculator is old. It's a beautiful calculator, although it is before it is before we had those fancy graphing calculators in my elementary years. And this is my elementary calculator, elementary school calculator, which it was here before the TI something that happened. I genuinely love the TI something, but this thing brings me back to like elementary school years, so it's kind of cute as its own. You see that? That gives you the value that you need. I'm not sure if you see it, but that shows you. So that is how I figured out is basically PO over P choke, which is equal to PO over P star. And we discussed last time that PO over P star is equal to, I believe, something like 1 plus gamma minus 1 divided by 2 ME, right? ME, which is now choke square. And it's going to be, I believe this was over here was PO divided by P star was gamma plus 1 divided by 2 gamma. Let me double check that. No, it's minus. Okay, so minus, so it's going to be gamma divided by gamma minus 1, right? Any questions about that? Yes. And which can, if this is 1, we figured out this is 1 plus gamma minus 1 divided by 2, which is equal to 2 divided by 2 gamma minus 1 divided by 2, right? Oh, you can't see it. Over here, which turns into, I believe it was 2 divided by, and it's plus. So we see over here that this is the internet working? It seems to be lagging on my tablet, which is bad. Gamma, and then it's going to be plus 1 divided by 2, I think. Am I correct? Yes, I think I am. Gamma divided by gamma minus 1. And this is equal to 1.843. Beautiful. This shows